Hello class. I hope all of you are doing well and are safe. So in today's class, we will be discussing the data modeling and data evaluation. Okay, and we need to know why we need the data modeling. Say, for example, let's have a simple example. This is our data, meaning these are the columns, say A, B, C. Okay, here are different numbers: 5, 6, 7, 2, 3, 4, 11, 10, 12. So, see, these are the data. Okay, so we always have some business questions. Okay, we need to answer those questions based on this data, and to answer those business questions, we need to use different data modeling and evaluation techniques. So that is what we are going to discuss about it. So what we will be learning today, the first one is supervised and unsupervised approach, then data profiling, data reduction, data classification, data clustering, and finally correlation and regression. And we'll be discussing all these issues briefly, and we will also show some uh, practical examples by using Excel in today's class. Okay, so what is data modeling? The data modeling is all about determining what data we want to capture for a specific purpose, meaning we have some questions in our mind and we want to answer those questions, okay, by analyzing the data. So the purpose of the data modeling is to answer some questions, and for that, this is a table. Say we have the different clients, okay, and how many units the clients have purchased and the price per unit. So from this, what we can see that the client A and client C, they are actually different clients. They are in different clusters. So that is why, see, their price is also different. See, when they are purchasing 200 units, the price is $20 only. But B and D, the client, so they are purchasing less amount, so that is why the price is higher. Okay, so here we can easily see different cluster, right? So if we use as a cluster analysis, so we can see that there are two types of clients. One is in the upper layer that is having more than, meaning that are buying more than 200 units, and we have lower clusters that are who are buying less than say 50 or 30 units. Okay, so this is one kind of analysis, clustering the clients. So what do you need to know about the data model? The first one is the target. So meaning we must have a target so that we can analyze based on the target. We will always have a target and we want to find that target. Okay, so a target is an expected attribute or value that we want to evaluate. Okay, an example, see, if we want to know whether a transaction is fraudulent, the target would be the fraud score. Okay, so we want to calculate the fraud score. And the second one is a class. So what is a class? A class is actually a manually assigned value. Okay, we usually assigned a value or assigned text for a different category of clients or customers or people, something like that. Okay, so for example, if a loan application, actually this should be loan application, if a loan application is rejected, it is marked rejected. So this is a class, okay, meaning that loan applications are the class. It is one kind of class. So that is what. So we now know that what is target. We need a target, and we also have a class. Okay. Then there are two approaches in data modeling and evaluation. The first one is supervised, and the second one is unsupervised. So in the supervised approach, we always have uh, some questions in our mind, and when we are trying to predict some future outcomes based on the historical data. So in that case, we will be using the supervised approach. An example, say, will a new vendor ship a larger order on time? So that is one example. And unsupervised approach is when you don't have a specific question. Okay, you will just analyze something. For example, do our vendors form natural groups based on similar attributes? Okay, and what are the approaches of supervised approach, some approach? So let's see, that is classification. Okay, so we predict whether the data belongs to one class or another, and similarity match. See, the group the data by attributes, similarity match. And classification is an example. Say we have, say for example, 5,000 companies in our report. So we want to know which companies usually report in December. So that is a classification. I mean, we will classify, say, based on the month. If the month is equal to 12, we will classify them as the December reporters. Okay, so that is one example of classification. And here is another example of classification. Say for example, we have customers and we have the units sold. So we can see that there are two types of customers. One group of customer usually orders huge volume, and the other group of customers do not order the huge amount. So the customer number 4, 7, and 10, we can make a cluster of those customers based on the number of units they order from us. So this is one example of clustering. See, here are the customers who are usually ordering, say, 20, 40, 30 units, and here are the customer groups who usually order, see, 600, 560, 578. So this is a classification of the customers based on the orders. This can also be said a clustering of the customers. Okay, so clustering is almost similar to classification, but clustering is calculated differently. Actually, how the customers are different from each other. If they have the minimum distance, they actually belong to the same group. So that is how we analyze the clustering. So we'll be find the undiscovered natural groupings in the data. So you can see that this is a group, this is a group, this is the group. So we can see that how the clustering works. So, and co-occurrence grouping, events that happen together. Okay, and some unsupervised approach. So see that the profiling, it usually identifies the behavior of the data. Say if you have 100 customers, okay, and how many days do they usually take to pay for the products they have purchased? So if the average is, say, 10 days, you can easily identify that some customers who will be paying, say, after 10 days or before 10 days. So we want to analyze those group of people who have abnormal behavior. Say for example, if the average time is 10 days, but the customers, few customers are paying after 30 days, so those customers are problematic. Okay, so we will be careful about those. So we can usually analyze the abnormal behavior of a group or population. So this is an example of data profiling. Okay, and the data reduction, it's actually a filter. It's a filtering, meaning we'll be filtering a certain data database based on some criteria. That is called data reduction. Okay, so in the profiling, so we will be identifying the objects or activity, then determine the types of profile, and we will be having a boundary or threshold. That is, in most of the cases, the mean value, meaning the average. Mean is the boundary or the threshold. We will be comparing the performance of other customers based on the mean of the whole customers. So we will be analyzing and interpreting the results, and finally we will follow up the expectations. Okay, here is another example. So we can see that we have the product A, B, and C. Okay, this is the price variance. Okay, so if this is the standard, see, this is the standard, so it is less, it is high, it is a little bit higher, so when you see is little bit higher. So this is how we can analyze the behavior of the uh, of something, of the data. Okay, see, these two values are more. Okay, this value is more, this value is more, so we will be caring about this. It will help us. Okay, then it's another example. This is a Benford law. These are the Benford prediction, and this is the real GDP in 2016. So this year we have more, equal, something more, but this year we have less. Okay, so we can analyze these profiling, uh, meaning we can analyze the abnormal behavior of the data by using the profiling. And say, for example, uh, usually the profiling is used in the criminal investigation. Okay, so the law enforcement usually use for the offender or criminal profiling. Okay, how does this compare with the profiling accounting data? So we have an average behavior of human, so the criminals will be doing something that is not that doesn't match with the average. Okay, and the data reduction is used to filter the results. So we will be identifying the attributes based on which we will be analyzing the data, and we will be reducing the data. So filter, interpret, and finally follow up. And the example of data reduction, see, for example, so in the internal audit, the auditors usually try to find the fraudulent activities. And let's have an example. See an example. Auditors will analyze the transactions that involve whole dollar numbers, because these numbers are more likely to be fraudulent. And that is why from this, so after reducing data, we have reached to this one, because we can see that this is the whole number, this is the full whole number, this is the whole number. So we have reduced data based on the whole number. Okay, and data clustering, it is used to identify groups of similar data elements and the underlying drivers of those groups. Okay, clustering algorithm usually calculate the minimum distance of all observations and groups those elements together. So we can see that there is a cluster over here. And the clustering, an example of the clustering is to identify the groups of transactions that may indicate risk or fraud in insurance or other payments. So, and the correlation, so here the correlation describes the degree of relationship between two variables. So if it is variable x and variable y, so how they are moving together. Okay, if x increases, y increases. See, if x increases, y increases. If x decreases, y decreases. So we can see there is a positive relation between x and y, meaning this is how we call the correlation. Let's have an example of the correlation. For example, say uh, there is a correlation between price and demand. Okay, see demand and here is the price. If the demand is 100 units, okay, price would be say 10. If the demand is 1000 units, price would be higher. Can you see that? So price increases with the demand increases. So they are positively correlated normally. And the final one is the regression analysis. This is the most important part to predict some variables than an outcome variables. For example, here we can see that the net income depends on sales, the company size, cost of goods sold, and other factors. Okay, so it means that net income is the function of many things. Okay, the function of sales, size, cost of goods sold, and some other factors. Okay, so here net income is the dependent variable and these are the independent variables. So we want to predict, we can predict based on the regression analysis. Okay, so we will be showing every single one that we have already discussed. I will show you how to practically work on those things. Okay, so thank you so much and welcome to the second part.